previous videos, we talked about the open-ended lab. It was mentioned that the open-ended lab has a scale to determine the levels of open-ended. There are level 0 to level 5. Level 0 is a totally closed-ended, while level 5 is the highest level of open-ended. It was also mentioned that when we want to conduct the open-ended lab, we still need the lecturer or lab instructor to facilitate the entire process. The open-ended lab is a part of the teaching and learning activities. It cannot be conducted without the lecturers or lab instructor. Secondly, when limited information is provided in the manual, our intention is to make it open-ended so that the student take more responsibility during the teaching and learning activities. We are expecting the students to prepare before coming to the lab, which very often students are not doing so. The main reason of this is that the culture of open-ended lab is not there yet among the students. Another part of the reason is that we do not provide necessary resources and reference accessible to the students. This leads to the students having no idea what they're supposed to do before going to the lab. They know that they're supposed to get themselves ready before the open-ended lab, but what specifically they need to prepare, they have no idea. We will have to look into the system, how we can help the students to participate more in preparing for the lab before entering the lab. Not only we need to make all the resources, informations, literature, as well as operating manuals easily accessible by the students. Probably we will have to give some guidance and supervisions to the students before the open-ended lab started. They need to know what they need to prepare, what they need to learn beforehand as a preparations for the open-ended lab. This table summarizes different levels of open-ended lab, where level 0 to 2 represent the traditional mode. Starting from level 3 onwards, it is classified under the open-ended lab. You can say that by definition, an open-ended lab will require the students at least to work out their own methodologies, as defined by level 3. Now let us look into the details of different levels. We have the typical profiles of different levels, and also the learning tasks of different levels. Let us go through this one by one. Level 0 is totally closed-ended. All the informations are included in the manual, including the guidance to the students how they can deal with the discussion part. Sometimes it may also appear in the mode of fill in the blank statements to emphasize the theories. This is fully guided, very limited challenge given to the students, and the entire teaching and learning process, it is more towards spoon-feeding. As for the learning tasks, this includes understanding and finding the correlations between the experiment and the theory. If you look at this kind of learning tasks, you will see that the open-ended level 0 is meant for the students to quickly understand certain concepts through experiments. Very limited higher thinking orders are involved. This is more suitable for the students who are exploring into some new theories and principles, which they are not aware in the first hand. More specifically, it is more suitable for primary or secondary school students. I would say as for higher learning institutions, we are looking into more higher levels of thinking orders. And in the context of Malaysia, the students has been exposed to experimental words since their primary schools. that have been quite familiar with experiments, how to make discussions and draw conclusions from the experiments. In this case, we do not need to repeat this in the universities. Personally, I would not recommend for level 0 for engineering programs. Second, level 1. The profile include provide operating procedures and datasheet that guides the data collection. Sometimes hints shall be given in the mode of questions for the students to do the discussions related to the relevant theories. Now the learning tasks involve digesting the procedures, find the relevant theory, and the students will have to work onto their own discussions. OEL Level 2 provide operating procedures without datasheet. The discussion is left open for the learner to evaluate based on the results. Now, on top of digesting the procedures and finding the relevant theory, there are additional tasks for the students. They will need to plan the data collections, which compared to level 1, the data collection part is guided, and then they will have to evaluate the results. The reason that the result needs to be evaluated, it is because the students are now planning their own data collections, which can be done correctly or wrongly. As compared OEL level 1, the guidance has already been given on the right ways to do the data collection. Because of this, the students will have additional tasks in order to test the validity, reliability, and accuracy of the results. Through this, the students are educated not to accept blindly whichever data is acquired from the experiment. This cannot be achieved through OEL 0 and OEL level 1. And then the discussions is left open. The students will have to work out the correlations between the parameters learned through the experiment and the theories learned from the lectures and references. Starting level 3, it will be considered open-ended. This is because the lab procedures are not given and the discussions is left open. What is given to the students, it will be the objectives and also the problem statement of the experiment. Because the lab procedures are not given, the students will have to custom design the experiment in order to meet the objectives and answer to the problems of the experiment. This leads to the learning task of developing the procedures. Since now the students are required to develop their own procedures, it will be depending on the levels of understanding and also the preparations by the students. The procedure design may be correct or may not be correct. This will still require the supervisions of the lecturer or lab instructor. Now the students are asked to design the experiment. Together with this, the students will have to identify the parameters to be studied and determine what kind of data are to be collected. Later, there shall be evaluations of the results. When come to the evaluations, the students might need to also evaluate the parameters and also evaluate the validity, reliability, and accuracy of the data. Lastly, the students will have to find the relevant theories. Next, we talk about level 4. In this case, less information are to be disclosed in the manual. Only objectives are given. The rest are left open. The meaning of open here is that it gives higher degree of flexibility to the students on how to carry out the experiment on the aspect that not clearly specified in the manual. Since we only provide the objectives, the students will have to formulate their own problems as long as it is in line with the objectives. They will need to analyze and define the problem based on the problem identified, which can vary among different groups. The students will have to custom design and develop methodology as well as the laboratory procedures in order to find solutions to the problem as well as meeting the objective as defined. After designing the lab procedures and the methodology, the students will need to identify the parameters to be studied and determine the data to be collected. Later, evaluations of the results shall be conducted. Now everything is open except for the objectives. The students will require the supervisions by the lecturer as well as the facilitations by the lecturer to help them through all this process. Any of this can go wrong if it is not properly supervised or monitored. Although the evaluations of the results seems to be similar, the depth and levels of analysis may differ. The higher degree of open-ended lab may need to evaluate the result more thoroughly due to larger degree of uncertainty due to the involvement of the students formulating their own solutions for the lab. Lastly, it will be level 5. Now everything is not given. It is totally open-ended, which can also be considered as free laboratory research project. And it is usually in the form of final year research project, requiring at least 1 semester to complete everything. Now the learning task here, it will be the most thorough, starting from scratch. The students will need to decide the experimental themes, analyze and define the problem, develop the methodology and the laboratory procedures, identify the parameters and data that needs to be collected, evaluate the results, and finally formulate theories. All these procedures are interrelated. There will be supervisions by the lecturers or lab instructor, which may need to help the students to fine-tune further in terms of the correlations and linkage between different steps here. This is about the 5 levels of open-ended lab. Now come to the practical aspects. Personally, I feel university level, by all means we should avoid level 0. The reason being is, by the time they are entering the university, the students have been quite familiar with the lab, how the experiment is being conducted, through their exposure in their primary schools as well as the secondary schools. The purpose of doing labs in the primary and secondary schools, especially in the primary schools, it is still knowledge-based, introducing the knowledge to the students. And then when they enter the secondary schools, there shall be hands-on practices. By the time they enter the university, we will expect the students have all this in place. Now we are training the students to really apply the experiment in solving the problems in the reality. The motivations is not introducing the students the relevant theories. The motivations is also not for the students to experience through experiment. Now the real motivations is for the students to really use experiments to solve the problem. It may seem to be similar, but now the focus is different. We are trying to simulate the challenges that the students are going to encounter in their working life in future. So with that, level 0 will be totally out of the consideration. Now how about level 1 and level 2? We would like to create a culture for the open-ended lab. A typical engineering program will have a series of lab work. In my institutions, we have Civil Engineering Lab 1, Civil Engineering Lab 2, and Civil Engineering Lab 3, which are offered in the first, second, and the third semesters of the engineering program. Just in case that students are not aware what they should do with the open-ended lab, we can go for the open-ended levels progressively. Let's say now for Civil Engineering Lab, which is being offered in the first semester, we can have level 1 and level 2. And then comes to the Civil Engineering Lab 2, which is offered in the second semester. We can have level 2 and also level 3. Now when come to the Civil Engineering Lab 3, which is offered in the third semester, we will have level 3 and level 4. And then for the projects in the final years, such as integrated design project, probably we can go for level 4. As for the final year project, which is research based, then we can have level 5. Now the entire program will have the open-ended lab at different level, where the level of openness increase progressively, putting more responsibility to the students as the programs go along. This is about the progressive design of the engineering labs. Another thing that I need to mention about this open-ended lab is that there are sometimes misconceptions. Many think that the meaning of open-ended lab is that the least information is provided to the students. Let's say now you are dealing with level 3. It is not as simple as you are not providing the lab procedures and not providing guidance to the discussions shall be equivalent to level 3. We will have to go back to the basis and the purpose of the open-ended lab. The open-ended lab level 3 is defined when the students are actually developing their own procedures. Whether or not the relevant procedures are given in the manual is just an indication whether it is OEL level 3. Let me give you a scenario. Let's say now the students are now doing the open-ended lab level 3. Manuals are given, where only objective and the problems are given. The rest are not given. Yet the students can still refer probably the lab report from their seniors, or probably the procedures as acquired from somewhere else, and then following exactly the entire procedures and going through all these tasks here. Now, effectively, the students did not really learn how to develop the procedure. By fundamental, this is still not level 3 open-ended lab. This normally happens, especially when the lecturers giving too much guidance to the students. Realizing the students did not prepare well for the lab, in order to save time, the lecturer gives some samples for the procedures and asking the students to follow accordingly. This leads to the difference between what is on the paper versus what is actually happening in the reality. At the end of the day, the quality of the learning, it will be as if open-ended level 2 or open-ended level 1. This defeats the purpose of having the open-ended level 3 in this case. Same principles apply to others. So as a lecturer who are conducting this open-ended lab, you will have to refrain yourself from delivering the lab or conducting the lab in the traditional mode. You will need to custom design your teaching and learning activities to meet the needs of the students, which may be different among different groups. You will need to closely monitor the progress and the performance of the students and make professional judgment how you can best helping the students to learn through this open-ended lab. Personally, based on my observation, many end up to be in this situation. On paper, everything is nice. They are open-ended. But what is in the reality? The quality of the learning as experienced by the students, it is as if not open-ended. And this defeats the purpose of having the open-ended lab.